Hello everyone. This video will cover the material for these 4 pre-class assignments and the discriminant post-class assignment, as well as doing some graphing with quadratics in Excel. Then I'll make one final video that will cover square roots, which are the inverses of quadratics. Okay. First of all, notice in front of you that you have the quadratic formula. What the quadratic formula does is find solutions to this problem. So it solves for x in a quadratic. The quadratic formula will work for any quadratic, whether it's factorable or not. Previous in this unit, we were factoring quadratics, and then after we factor them, we used what was called the zero factor property to find the solutions, to find the x values. Now you can just use the quadratic formula for any quadratic, whether it factors or not. So you notice we've built up other methods of solving quadratics, and then the last method you learn, the quadratic formula, will solve any quadratic. And what these first few pages cover is what's called the discriminant. The discriminant is one particular section of the quadratic formula. It is the section b squared minus 4ac. So as I rewrite the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now notice there's 3 situations for the discriminant. If b squared minus 4ac equals 0, so the 3 situations are the discriminant being less than 0, the discriminant being equal to 0, or the discriminant being greater than 0. There's 3 cases. If the discriminant is equal to 0, that simply means that your solution is negative b over 2a. So you only have one solution. If your discriminant is greater than 0, if this value in here is greater than 0, then you have a square root of a positive number. So that'll just simply give you 2 real solutions, like normal. However, if your discriminant, if b squared minus 4ac is less than 0, which means it's negative, if this value is negative, that means you're taking the square root of a negative value. Whenever you take the square root of a negative value, that is an imaginary number. So therefore, if your discriminant is less than 0, that means you have 2 non-real or complex solutions. So these are the 3 cases that the discriminant tells us. Either 2 non-real, 2 real, or 1 and only 1 solution. The case where there's only 1 solution is when the vertex hits the x-axis. So here, if we notice here, our vertex is going to be negative b over 2a, which is equal to negative 6 over 2 times 9, is equal to negative 6 over 18, which is negative 1/3. So now f of negative 1/3, so we know this is where the vertex on the x-axis is going to occur right here at negative 1/3. So now let's find f of negative 1/3. And that equals 9 times negative 1/3 squared plus 6 times negative 1/3 plus 1. So this equals 9, negative 1/3 times negative 1/3 is positive 1/9. 6 times negative 1/3 is negative 6 over 3, which is 2 plus 1. 9 times 1/9 is 1 minus 2 plus 1, which equals 0. So f of negative 1/3 equals 0. So you notice the vertex of this parabola is going to occur right here. And then when x is 0, so the y-intercept, f of 0 equals 1. So our 2 points here are negative 1/3 comma 0. There's our x-intercept, and our y-intercept is the point 0 comma 1. So this is what the graph looks like. So whenever the discriminant is equal to 0, you have one real solution, the vertex is going to touch the x-axis. So now if the vertex moved up and I had a graph that went like this one will have 2 non-real, because notice that does not cross the x-axis. This has 1 real, and the other case is where the vertex is down here and it does this type of thing. So this one has 2 real. So if I had the function for this graph, the discriminant would be less than 0. This has 2 non-real solutions, which means it has no x-intercepts. This function f of x is never 0 on this parabola. Here it's 0 once, here it's 0 exactly twice. And here's an example. If you graph this less than 0, and then here's one where it's greater than 0. So now let's look at an application. The wine consumption by Americans for the years 85 to 2005 can be modeled by this function where x is the number of years after 1995. That's important because we like to have the first year be year 0. So x is the number of years after 1985. And y is the number of ounces of wine consumed. So if we're starting in 1985, I don't care about these 3 coordinates. I'm going to let this be 0, which is equal to 1985, right here in the middle. So we only care about this top quadrant, top right quadrant. So this is WX, this is ounces of wine consumed, and this is X, which is years after 1985, and wine is ounces per person. So the first thing I want to do is discover where W of 0 is, which is equal to 49. So that means in 1985, there was 49 ounces of wine consumed per person per year. So we'll just mark a dot right here and we'll call that one 49. Now let's find the vertex, which is going to be negative b over 2a. So that's negative 2.06 divided by 2 times 0.0951, which equals a negative of a negative is a positive, so that's 2.06 divided by that. Let's do it in our calculator. So 0.0951 times 2, 0.1902. So now we do 2.06 divided by 0.1902 equals 10.83. So what that means is 10.83 years. Remember, this is X. That's my vertex point. So if this is year 0, let's go 2, 4, 6, 8. Let's call it 10 right here. So this is the point 10.83. So notice that this graph, since our leading coefficient is positive, it's going to do this type of thing. It's going to open up. So let's find how many ounces of wine were consumed 10 years after 1985. So let's do W of 10.83 equals, go back to our calculator. So I'm going to do this value squared times 0.0951 minus 2.06 times 10.8307.045. We'll just go that far. Plus 49 equals. So that's 37.8 ounces. So here's, we'll call this 37.8. So here's that point. So our wine consumption does this kind of thing. comes down, it bottoms out right here, and then it keeps going off this way. So wine consumption actually decreased between 1985 and 1995, and then after 1995 it begins to increase again. I know that because this is my vertex of my parabola. It's the point 10.83, comma 37.8. Label the axes, did that. What is the number of ounces consumed per person in 1985? That's W of 0, which is 49. In what year does the model predict the number of ounces of wine consumed per person is 40? So that's going to happen in between 49 and 37.8. So it's actually going to happen twice, because 40 is roughly right here. So it's going to happen two different times, where you simply set the function equal to 40. So you go 40 equals our function 0.0951x squared minus 2.06x plus 49. Now I want to solve this for x using the quadratic formula, but I have to set it equal to 0. So I want to subtract 40 from both sides. So 49 minus 40 is 9. So over here it ends up with 9. And over here we just have 0. So now let A equal 0.0951. Let B equal negative 2.06. And let C equal 9. And then use the quadratic formula. All right. And to do that, you plug values in. So I'll do it here with a little bit simpler problem. So I'm going to find the x values, the solutions to this equation. So I have A equals 3, B equals negative 6, and C equals negative 5. So the quadratic formula says x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Notice you cannot forget your signs in here. That's very important. So this means x equals 6 plus or minus the square root of 36 plus, that's 12 times 5 or 20 times 3, which is 60 over 6, which equals 6 plus or minus the square root of 96 over 6. Which will give us 2 decimals. 6 plus square root of 96 over 6, and 6 minus the square root of 96 over 6. And then to simplify it, let's do 96 divided by 16 equals 6. So this equals 6 plus or minus. So 96 is equal to 16 times 6. So that is, so 96, the square root of 96 equals the square root of 16 times 6. So 16 can come out as a 4, so we have 4 root 6 over 6. And these can all be reduced by 2, so it's 3 plus or minus 2 root 6 over 3. And there's your 2 solutions. Notice they'll both be decimals. 3 plus 2 root 6 over 3, and 3 minus 2 root 6 over 3. So perform that same operation using these 3 values. Now let's go down here and talk about domain and range. What is the domain of this problem? What values does x assume? Well, it assumes everything from 0, year 0, out to infinity. It never stops. What about the range? Well, the smallest value the range attains happens right there in the vertex. It's 37.8. and it extends out to infinity as you look at this graph. So if I use my colors that I've used in the past, My domain is from 0 to infinity. And my range, my smallest value my range gets to is 37.8. And then that arrow goes off to infinity. Alrighty? There's another example of a addle, which what I want you to do there is work on that because that's a homework question. Same type of stuff. You can answer all those questions. Now what I want to do is jump to the Excel portion. And let's graph some of this in Excel. So let's figure out how to do that again. Let's jump back, open up Excel. Once again, you let year 2000 be 0. You want to always start with a base point. Makes it much more simpler. Makes it much simpler to interpret the graph. So I'm going to let this be X, which is the number of the years after 2000, and let this be the number of adoption. Or I'll just call it adoptions. So what this table says is this is the number of U.S. foreign adoptions from the top 15 countries. So this is foreign adoptions by people in the U.S. So first let's jot down our information. So we have 0, 1, and that's my step size. It goes up by a year all the way out to 9. And then you want to actually type in those numbers. So 18,120, 19,087, 21,320, 22,911, 22,710, 20705, 19,741, 17229, 12,782. Enter. Now it says create a scatter plot in Excel. So what I'm going to do is just highlight my values, go to Insert, Scatter, and I'm just going to pick the very top left one. And there it is. It's kind of ugly. It doesn't really give me any information. It's just some points on a graph. But you notice it kind of has the shape of an upside down parabola. Notice that's the shape. What shape does it have? Does the data seem to be increasing or decreasing? It's actually doing both, which is characteristic of a parabola. Its f of x is increasing out to about right here, and then f of x begins to decrease. There seems to be a maximum right here. So now what I want to do is go to my layouts, and I'm going to go all the way down here and click Layout 9. So notice it puts in all this information. I want to click on this right hand side and delete it. And I'm going to click on the little lines in here and delete them. I'm going to title my chart U.S. Foreign adoptions. My title down here is years after 2000. And over here is adoptions. I always want you to label your graphs. Now notice I'm fitting it here with the linear equation. And my R squared value is 0.16, which is very, very low. Remember, we want that value to be at least 0.8. So we fit it with the linear equation, and the R2 value is 0.1605. Now let's fit with the quadratic equation. How do I change it? Well, what I do is I get right on the line. See how it says Series 1, Trend Line 1, and I right click. When you right click, it says Format Trend Line. You click that. Now this thing might come up on the right hand side of the window if you're using a newer version of Excel. But what I'm going to do here is call it a polynomial of order 2, which means quadratic. Display equation, all this stuff, everything else is set, and just hit close. Now look at the equation it gives me, and look how good the fit is when I use a quadratic equation. R squared equals 0.938, and this line seems to really map my data points. Notice my leading coefficient's negative, which leads me to believe it opens upward, or the curve goes up instead of this way if it was positive. And now I can use this equation to answer these questions. Use the best fit function to predict the number of U.S. foreign-born adoptions in 2010. So what I'm going to do there is let x equal 10 and plug it into this formula and simplify. All right. Exercise 2, we could do the same type of thing. So here, beer in gallons, you can do the same type of thing. Exercise 3, match each scatter plot. So notice there's two lines. One has a positive slope, one has a negative slope. Looks like this one has the positive slope. So this one's A, this one's B. And looking at our two quadratics, this one opens down, so it should have an A that's negative. The leading coefficient should be negative like this one, which is D. And this one then would be C. All right. And then what you could do is you could just simply hit Control C and copy, or you can right hit and go to copy, open up a Word file. Make sure you put your name and such, and then just hit Control V to paste, and it pastes it into the file. That's what you'll have to do for your Excel work right here, your Quadratics and Excel homework assignment. Just taking a look at it. Look, there's only 2 questions. So what you need to do is, here's your values, here's your X column, here's your Y column. It wants the linear and the quadratic function, which one has the best fit, and then I want you to email me that Excel plot. So there's 2 questions, so I want 2 of these graphs. Make sure it has the function, and you label your axes. All right. So there'll be one more video for this unit that will cover the inverses, which covers square roots. So that'll cover these 2 assignments. All right. So let me know if you have any questions out there. I have one more video for this unit, and that'll be it. Thank you, everyone, and have a wonderful day.